Okay, so moving on to probability now. First thing is draw the diagram, draw the Venn diagram. So draw the Venn diagram. Sometimes the question is going to prompt you to do this and sometimes it won't. But you just need to make sure that you want to take advantage of the fact that it's a lot easier to know which values to use and which values you're interested in if they're laid out in front of you sensibly in the form of a Venn diagram. So go ahead and just produce that sketch for yourself. Things to look out for. Straight away, I realized there were going to be 3 different groups: developing software, system support, and networking. So I knew it was going to be 3 overlapping circles. Be careful to check out whether they will all overlap. I knew they would because some people took all 3. In other questions, there may not be overlap between all 3 of them. So be careful what your Venn diagram is going to look like. Potentially, you could have a Venn diagram like this. You could even have a disconnected Venn diagram, and even a Venn diagram that has one set fully within another, and then maybe some overlap across the 2 of them. Okay, so just be on the lookout for keywords that will let you know what sort of Venn diagram you're looking for. All right, just to remind you to be on the lookout for phrases like given that. The given that says that you're reducing your field of interest from the entire set just down to a subset. So in this particular question, we were told, given that the randomly chosen student is eligible to become a technician, so I'm only interested in those who can become technicians, which means I'm only interested in those who do system support and networking. System support and networking was 40 students. Those are the ones I was interested in. After the given that statement, it says, find the probability that the student takes all 3. That led to 4 out of the 40. So the Venn diagram let me know exactly which values I was interested in. Apart from that, there's always this formula which can and should be used when we have given statements. This is more useful when there is not a diagram in front of us, but both of those hand in hand should get you towards your correct answer. Okay, next, show all of the outcomes. All of the outcomes from tree diagrams, all of the outcomes from discrete random variables. Any way that a question has been asked, you want to make sure that you're in a position to use all of the outcomes, okay? Especially if there's a sensible number of them for you to produce, you want to write them all down. If there's an unwieldy amount, then you just definitely need to know all of the outcomes that can happen, potentially picturing them in your head or just writing a list of them somewhere. Okay, next, setting out a table for all values of x when you're working with discrete random variables. Very first thing that I did is I made a table and I put in the values 0, 1, 2, and 3. I then followed the specific rules that are in place for me to know an expression for each of their probabilities. Then I set all probabilities equal to 1, and from there I was able to solve for k. All right, after you've solved for k, don't forget to write the actual numerical values back into the table for reference later on during the question. Okay, rewrite probabilities with equals to. All right, so we're talking about the less than or equal to symbol or the greater than or equal to symbol. Here, we'll ask for fewer than half games, and naturally that turns into fewer, which is less than 4.5 games. 4.5 is a non-integer, so we turn that into less than or equal to 4. This is the preferred form. This is the form that the tables are referring to. This is the form that your calculator is referring to. So get your calculations into that form. With that said, use your calculator for binomial probabilities. The tables are limited. They only have p-values in multiples of 0.05, and they only have n values. They only have some specific n values. Your calculator will be able to be used for all situations, so take advantage of that. Okay, once again, rewriting those probabilities into a form that we want. But more than that, we need to make sure we're reading these phrases correctly, all right? More than 440 means that 4 is not going to be included. So some of these terms, at least, at most, and more than, just take a second in your head to make sure that you've interpreted them correctly. At least 4 heads. This time round, the 4 is going to be included. So at least versus more than, make sure that you're interpreting those correctly. Wherever you end up, you do want to make sure that you've got an equals to inequality. And then obviously we need to rewrite as the 1 minus for us to calculate further, either on our calculators or from the tables. Rewriting probability statements correctly is vitally important. Some common mistakes that I see and have seen, these are not correct, okay? The probability that x is greater than or equal to 3 does not equal 1 minus the probability that it's less than or equal to 3. 3 cannot be involved on both sides of that equal sign. Similarly, the probability that x is less than 3, it might feel like you've done it correct because you use different numbers on each side, but 3 is not included in either of these sides of the equal sign. So let's just make sure that we're getting that correct. Think of the list of numbers if you need to. So a list of numbers, and if I want everything that's greater than or equal to 3, that's these numbers. And to get these numbers, I can eliminate everything less than or equal to 2. So the probability that x is greater than or equal to 3 is 1 minus the probability x is less than or equal to 2. Okay, another one of these to draw your attention to is this double-sided inequality. Various mistakes are made here. Some people try to use a 1 minus because they're reading this as x is greater than or equal to 3, and that they naturally want to go towards a 1 minus for that. That's never the case. For double-sided inequalities, we are going to subtract 2 less than or equal to statements. So once again, using these list of numbers, if I want to end up with everything in between 3 and 8, including the 3 and the 8, I'm going to start off by thinking of all of the numbers less than or equal to 8. And that's where we get this first statement from. After that, I'm going to subtract everything less than or equal to 2. These are getting cancelled out. That's left me with the numbers I was interested in. I used 2 less than statements to produce the range of values that I wanted to use. Okay, so don't try and get fancy with this. It is 1 less than statement minus the other. Okay, so here we're going to look at the test of independent. We can use this test of independence only if we've been told that 2 values are independent. So either we've been told they're independent, so we know that this is true, or we want to test whether they're independent by checking if this is true. But we can't just go ahead and just assume that we can use this unless the question's told us they're independent, or we're checking that these 2 values or these 2 sets are independent from each other. Make sure you've seen that keyword, make sure you've seen that trigger word, independent, before you go ahead and apply this situation.